Hello everyone, welcome back to our channel Elevate Learning Hub. Today we are going to be discussing the topic Retrieval-Augmented Generation, which we say as RAG as well. So let's get started. Firstly, we'll be talking about the components of Retrieval-Augmented Generation. It combines two fundamental components, retrieval and generation, to create a powerful system for question and answering the content creation. Here's an overview. As a part of the retrieval component, this part, the system is responsible for searching and retrieving relevant information from the database of documents. It uses techniques such as indexing, ranking, and query expansion to find the most pertinent documents. Generation of these component, once the relevant documents are being retrieved, the generation component takes over, and then it uses the large language models to process the retrieved information and generate the coherent and contextually accurate responses based on the user queries. So what is the benefit around this? It is the ability which provides answers based on the existing knowledge, which we say the retrieval model, while also generating contextually. It has rich responses from the generation side, and it combines both the strengths of both the world to deliver high quality answers. The use cases which we have recently seen as a part of the RAG, it's been useful for question and answering across large document collection, where traditional search engines may fall short in providing concise and informative answers. RAG is really powerful. Also, onto the fine-tuning. Successful implementation of this approach often involves fine-tuning of large language models on domain-specific data to improve the quality of the generated responses. Now we'll be talking about the role of the large language models in NLP. These models have revolutionized the field of natural language processing by their ability to understand and generate human-like text. While advances in deep learning and neural network, large language models have become valuable assets in various natural language processing tasks, including language translation, text summarization, chatbot development. One of the key strengths of large language models lies in their capability to learn from vast amount of data of text. By training on the massive data sets, large language models can capture complex linguistic patterns and can generate coherent and contextually appropriate responses. That enhances to produce high quality output that can be indistinguishable from the human generated text. Large language models are trained using a two-step process, which is a pre-training and a fine-tuning. During pre-training, models are exposed to large corpus of text data and learn to predict the next word in a sentence. This helps develop a strong understanding of language structure and semantics in it. In the fine-tuning phase, the models are further trained on task-specific data to adapt their knowledge to specific domains or tasks. The versatility and effectiveness of large language models make them a powerful tool in advancing the field of natural language processing. They have not only improved the performance of existing NLP systems, but have also opened up new possibilities of developing innovative applications. With continued research and development, large language models are expected to further push the boundaries of what is the next natural language processing can do as a part of the understanding and generation. Large language models represent a breakthrough in natural language processing and allow machines to understand and generate human-like text at an unprecedented level of accuracy and fluency. Some of the key role of large language model in NLP are that it can comprehend nuances of human language, making them adept at tasks such as sentiment analysis, entity recognition, language translation. They can also generate the text. Large language models excel at generating coherent and contextually relevant text. This capability is invaluable for content generation, chatbot, and automated writing. And even they do the question answering. Large language models are particularly powerful in question answering. They can read the given text and provide accurate answers to questions posed to natural language. They can also do summarization. Large language can summarize lengthy documents or articles, distilling the most important information from the concise form. They can also do the conversational AI. They serve as the backbone of conversational AI systems, enabling chatbot and virtual assistants to enable the meaningful and context-aware conversations. As a part of the information retrieval as well, large language model can be used to retrieve relevant information from large corpus of data, which is crucial for applications like search engine and document retrieval. From a customization perspective, large language models can be fine-tuned for specific tasks or domains, making them adaptable to a wide range of applications. From the question answering over PDFs, the document accessibility is very important. PDF is widely used format for storing and sharing documents. However, extracting information from PDF, especially in response to specific questions, can be challenging for users. Question answering over PDF enhances the document accessibility, and with the efficient information retrieval for researchers, students, and professionals, the lengthy PDF documents which are time consuming, with the help of question answering systems, streamline this process and enable users to quickly locate the information that they need. It enhances the user experience as well in various domains, including medical, legal, education, and various other fields. From an automation and productivity standpoint, by automating the process of extracting answers from PDFs, organization can save their time and resources. And it also provides scalability. As the volume of digital content continues to grow, scalable solution for question answering over PDF become increasingly important. Today, large language model can handle the large data sets and diverse document types, and in various industries with the growing demand of efficient information retrieval from extensive collection of PDF documents. For example, let's take for a legal firm which has multiple documents departments collaborating to process updated information. For legal cases, their task often involves having substantial volume of documents shifting through them and extracting relevant case information, which is labor intensive, which large language models can do in seconds. Now we'll be talking about how generative AI technology has supported ChatGPT as well as DALI 2 or Codex has been generating a lot of attention. This sparked curiosity in many who want to know that what's behind the impressive performance. ChatGPT and generative AI fall into category called artificial intelligence generated content, and this means they are about using AI models to generate content like images, music, written language, and this is the whole idea to create content faster and easier. Now we'll be quickly dwelling upon instructions. In instruction 1, we can see the astronaut riding a horse in a photorealistic style. And in instruction 2, we have given a prompt, which is teddy bear working on a new AI research on the moon in 1980s. In both these artificial intelligence generated content, extracting and understanding intent information from the instructions being provided by human and generating the content according to its knowledge is something which has been done by the LLMs. With more data, bigger models, these AI systems can make things look and sound realistic with high quality. Now we'll be focusing on the types of artificial intelligence generated content. These models can typically be divided into two categories, unimodal and multimodal. Unimodals operate by taking instruction from the same type of data as the content, while multimodal are capable of receiving instruction from one or more type of data and generating content in other type. The following figures shows that the two categories of these models, which is in above unimodal, we can see that we have given one instruction, and in multimodal we have given multiple instructions to generate the content with the help of the prompts. But if you would see the result in both the scenarios in multimodal, though the instructions are many, but it is generating a single output, which is the cat. Now we'll be focusing that what is the foundation model of these LLMs. Speaking of LLMs and GenAI, we cannot overlook the significant role which transformer models play, and they are the backbone architecture of many of these models like GPT, DALI, Codex, and so on. transformer started out to address limitation of traditional models like recurrent neural networks when dealing with the variable length sequences and context, and the heart of the transformer is its self-attention mechanism, which allows the model to focus on different parts of an input sequence. It comprises an encoder and a decoder, and the encoder processes the input sequence to create the hidden representations, while the decoder generates the output sequence. Each encoder and decoder layer includes multi-head attention and feed-forward neural networks. Multi-head attention, a key component, assigns weights to these tokens based on the relevance and enhances the models. The transformer inherent parallelism minimizes the induction-based biases and makes it ideal for large-scale pre-training and adaptability. Transformer architecture has dominated the natural language processing with two main types of pre-training models based on the training data: masked language models and the autoregressive language. So masked language model predicts masked tokens with a sentence, while the autoregressive models focus on predicting the next token given the previous one. So the categories of the pre-trained LLMs, which you can see in this graph as well, you can see two types of information flowing, indicated which by the lines. The black line represent the bidirectional flow, while the gray lines represents left to right information flow. There are three main models: encoders, models like BERT, which are trained with context-aware objectives, and decoders like GPT, which are trained on autoregressive objectives. Encoder and decoder models like T5 and BART, which merge both approaches, and these models use context-aware structures as encoders and the left-to-right structures as decoders. Moving forward, we'll be talking about the reinforcement learning from the human feedback. To improve the artificial generated content alignment with the user intention, there is a reinforcement learning which comes from the feedback, and it's applied in models like Sparrow, InstructGPT, ChatGPT, and it involves three steps, which is pre-training, reward learning, and fine-tuning. With reinforcement learning, in reward learning, human feedback on diverse responses is used to create reward scalars. Fine-tuning is done through reinforcement learning with proximal policy optimization, and it aims to maximize the learned reward. Now we'll be focusing on GANs, which is generated adversarial networks. They are widely used for image generation, and GANs consist of generator and discriminator. The generator creates new data while the discriminator decides if the input is real or not, and the design of the generator and discriminator influences GAN training and performance. Various GAN variants have been developed, including LabGAN, DCGAN, and many more. And the following graphs illustrate some of those categories of vision onto the generative model itself. Although GAN's models are not the focus today, but they are essential in powering multi-model applications such as diffusion models. So we thought that we'll cover this as well. Now coming on to the application of large language models, chatbot and computer program that mimic human conversations, text-based interfaces, they use large language models and have various use cases like customer support answering common questions. Our chat from the PDF document is basically going to be talking about that notable example, that Zia voice, which is being developed by Microsoft, which expresses empathy, and Google's Mina, an advanced chatbot. Now Microsoft has also developed Bing, which incorporates ChatGPT and opening up the new possibilities of chat development. We also have knowledge graphs, which has been showing that it illustrates the relationship amongst the current research areas and related companies, and it is denoted by the blue circles applications, by light blue circles, and accompanied by green circles. And these chatbots are not only having the vast possibilities to develop applications in arts, design, music generation, education, but it's beyond the imagination, which cannot be stopped here. Now we'll be talking about that prompt learning will freeze the language model and directly perform few shot and zero shot learning onto it. This enables large language model to be pre-trained on large amount of raw text data and be adapted to the new domains without tuning it again. Hence, prompt learning could save much time, and traditionally prompt learning involves the model with a task that it can be done in multiple stages: prompt engineering and answer engineering. Prompt engineering involves prompt which can be either discrete, which could be manually designed, or continuously added to the input embeddings. And answer engineering, after formulating the task, the generated answer must be mapped to the correct answer. Besides that, single prompt, multi-prompt methods combine multiple prompts for better predictions and prompt augmentations. Moreover, in context to learning, a subset of prompt learning has gained the popularity, and it enhances model performance by incorporating a pre-trained language model and supplying input, label pair, and task-specific instructions to improve the alignment with the task. Overall, in the dynamic landscape of language modeling, tools and applications, the graph below shows the illustration of language model engineering with increasing flexibility of x-axis and rising the complexity along the y-axis. This graph shows the bird's-eye view of the choices and challenges developers faced in the research companies. Emerging RAG and prompt engineering architecture, the image source shows OpenAI, Cohere, Anthropic, which have been pushed the boundaries of what language models can achieve. Along the diagonal, the evolution of prompt engineering is displayed from the static prompt to templates, prompt chaining, RAG pipelines, autonomous agents, and prompt tuning. On the flexible side, optics like HiSec and LangChain have excelled, presenting broader horizons for those seeking to harness the versatility of the language models. This graph serves as a snapshot of the ever-evolving landscape tooling which is there in the language model and prompt engineering today. And it also provides a roadmap for those navigating the exciting possibilities into the space moving forward. What are the limitations of generative AI? Generative AI models such as GPT-3 have been trained on vast datasets containing text from internet. While this training process equips them with a broad understanding of language and context, it also introduces limitations. These models can only generate text that aligns with the patterns and information present in their training data. As a result, their progress may not always be accurate or contextually relevant, especially when dealing with the niche topic or recent developments. Now we'll be talking about that how transforming customer support with RAG. As a part, you can imagine that you're the owner of a thriving e-commerce platform company and selling a wide range of products from your electronics to fashion, and you have recently integrated your chatbot to assist your customer with inquiries. But you're stating to see its limitations. Let's explore how Retrieval-Augmented Generation RAG can help you overcome these limitations and can enhance the customer support experience. Limitation of traditional large language models. Your existing chatbot is built around the traditional large language model while it's knowledgeable about the general product information. Your customers are increasingly seeking more specific and real-time assistance. So here are some challenges you have encountered. Product availability. When the customers inquire about the availability of specific items, especially during the sales or promotions, the LLM can provide information based on its training data. Not only that, it does not have the access to the real-time inventory, so the shipping and the delivery details which customers frequently ask about the shipping times, tracking information and potential delays, the LLMs can provide standard shipping policies, but it cannot offer real-time updates onto the status of individual product. And also onto the product reviews. Shoppers wants to know about the recent product reviews and ratings to be the informed decisions. The LLM lacks the access to the latest customer review and sentiment analysis unless we provide that integration and we integrate with their customer 360 data as well. Then coming on to the promotion and discounts, customers seek information about the ongoing product discount and specialty offers. The LLM can only provide the details on the data on which it is being trained on and missing on the time-sensitive deals. Today, now when we be going to be introducing RAG into the e-commerce support system, retrieval of real-time data with RAG, your chatbot can connect to your e-commerce platform database and warehouse in real time, and it can retrieve the latest information about the product availability, stock levels, shipping status, incorporating users. And this is all come as a part of the RAG, which can analyze, scrap customer reviews, ratings from your website, social media, and other sources, which was not available previously. It was a lot of integrations which were being required, but now it can then generate the responses on the fly itself, can include recent reviews, helping customer make the informed choices. The dynamic promotions rack can access your promotion database and provide up-to-date minute details of ongoing discounts, flash sales, and limited time offers. It can even suggest personalized promotions based on the user browsing history. Not only that, order tracking as well. Rack can query your logistics system on the real time to provide customer with the real time tracking information for their orders, and can also proactively notify customer of any delays of the issues. This was not happening in the traditional LLMs model before, but now with Rack coming in, this is a huge change into the transformation which we now we'll be focusing on the retrieval key concepts and the components of RAG. To talk about the retrieval component is responsible for searching and selecting relevant information from a database or corpus of documents. Moving forward from a generation component perspective, once the relevant documents are retrieved, the generation component takes over and it leverages large language models such as GPT-3, GPT 3.5 to retrieve and generate the contextual accurate responses. It then moves into the interaction loop, where retrieval augmented generation often involves an interaction loop between the retrieval and generation components. Moving forward, onto the fine tuning, successful implementation of this approach often requires fine tuning of LLM on the domain specific data. Fine-tuning adapts the model to understand and generate content relevant to the specific knowledge. On the latent space representations, it retrieves all the models often convert the documents and queries into latent space representation, make it very easier to compare the ranked documents based on their relevance to a query, and based on the attention mechanics, both the retrieval and generation components typically employ attention mechanisms which help the model focus on most relevant parts of the input documents and queries and improve the accuracy of the responses. Moving forward, we'll be focusing on the RAG architecture. Onto the RAG architecture, this is a framework that synergies between two vital components. Retrieval model. This component specializes in searching and retrieving relevant information from extensive data sets such as documents, articles, or databases. It identifies passages and the documents that contains information related to a user query. Onto the generation model, on the other hand, the generation model excels in crafting coherent and contextually rich responses to user queries. It's often based on large language models like GPT-3 and so on, which then generate human-like text, which has been shown into the architecture as well. Now we'll be focusing that how RAG has the data ingestion pipeline. Onto the data ingestion pipeline, it prepares the document preparation, then the indexing is being done, and then it stores the information. For the data processing pipeline, the content is being retrieved from web pages, text documents, PDF documents, and being extracted and split it into multiple chunks of text, which then goes to the embedding models, and then with the vector embedding in the metadata, it's being stored onto the vector database itself. We'll be talking about the challenges of retrieval augmented generation. Yes, it does have challenges onto the data quality and relevance, but when it has issues with the noisy data, biases, and fairness, which it impacts the retrieval and generation of the authentic data. It also has issues while it has integration complexities, which is difficult in model, the compatibility of the models and balancing latency in the computational efficiencies. From a scalability perspective, it sees challenges with indexing efficiency and model scaling to large data volumes, and it also looks out for the evaluation metrics where the complications due to lack of gold standards and diverse user needs are being needed. From a domain adaptation perspective as well, complexities are required to incorporate domain-specific knowledge and data availability sets as well. So how the generation challenges in these RAG is being addressed? Yes, RAG does have hallucination issues where models may generate inaccurate or fictional details once given the inappropriate prompt. From an irrelevance concerns perspective, we can give the users appropriate queries so that the response may lack the direct relevance to the user queries when the inappropriate prompt is being given. So we have to focus that the prompt which we've given is exactly as per the requirement of the user as well. Then in the biasness of the response, which is potential to some harmful or offensive content, then we have to validate that. In addressing these challenges, we need to strategize to mitigate these issues also. What are the strategies to tackle these RAG challenges? We have to have the data augmentation being done to have a rich data set with the metadata or structured data for the richer context. We have to have the optimized embeddings, which refines embeddings to improve the context capture and response which is being generated. And also we have to focus on advanced retrieval techniques which implement semantic and hybrid search for better retrieval precisions. We can also have multi-purpose use of the LLMs. We can expand the LLM application to augment RAG system capabilities as well. Now we'll be focusing that how we have to rewrite the query for RAG. While we have to write the query for RAG, we have to optimize queries for better retrieval results. We have to expand, rephrase, and adapt user queries. We have to leverage LLMs for query expansion, and we have to utilize the synonyms which are related to these terms and enable conceptual and multi-language expansion. While we'll be generating the effective prompts with the LLMs, we have to refine and contextualize these prompts for retrieval and employ multi-steps prompt for complex queries as and when required. Also, RAG help us enhance the response by leveraging the user history. So there is a challenge in RAG system that recurrent user queries leads to unnecessary computational cost, but it has also been seen in the past that it enhances the responses with the user history. The memory cache of the question reduce latency and cost, and the consistency and accuracy in the response are being maintained. To have the memory user history mechanism, we can have key values stored for efficient question answer retrieval, and we can have vector database implementation for large scale memory. For advanced RAG system exploration, we can look out to integration with the tools like Lambda Index and Phoenix, and continuous improvement through the performance monitoring can be observed. Concluding on to today's presentation, we spoke about understanding the RAG systems, their insight into AI evolving landscape through RAG technologies, strategies and techniques for RAG development and implementation, the dynamic AI field which is staying abreast with the new developments and continuous explorations and innovations which are being emphasized. Looking ahead, we'll be inviting you for further learning and experimentations, and with the recognitions of this, we look forward to stay connected. So this is all for today. If you like this, please do like the video and subscribe to our channel. Thank you.